channel, and today I'm going to be talking about calculus problems and a review. So in our past playlists, we have made lots of videos on trigonometry, calculus, and physics. So if you want to look at a specific calculus subject, please visit one of those videos because they cover it deeply. This is just basic calculus, so the very basic integration and most of the basic derivatives techniques, including the product rule and quotient rule, are all in this video. In the next few videos, we're going to be making a specific review for a specific subject, like integration review, just for all of the integration techniques. But this video is just for all the basic integration and derivative techniques, but you could say it's more advanced for derivatives. So let's begin. So we have 7 problems over here, which we're going to solve today. We have a derivative problem, an integral problem, a limit problem, a partial derivative problem, another partial derivative problem, another integral problem, and then a differential equation problem. So as you may notice, these are the ones that are in basic calculus, and in 7 and 4 and 5 are going to be in more advanced calculus. So that's why I'm saying this is a more basic calculus video, because we're going to be covering mainly this, which is technically an advanced version of derivatives. These integral types are all basic, and this derivative, even you could say, is basic. This limit is very basic, and these are a little advanced, kind of just like a hint to show. So now let's start. So to start with the first one, let's first make a border. So we have the sine of x, and then the cosine of x, all over 9x squared plus cosine of x. And we need to take the derivative of this. So as you may know, that we could use the quotient rule over here because we have a quotient. So first, we need to find the derivatives of each. We can do this in a whole jump correctly, but since this is a review, we want to actually recover and review all the most basic concepts so we can say that we're the masters of it. So I'm going to walk step by step to solving this. So first we need to take the derivative of this, and then the derivative of this. Why in this order? Well, we're not going to implement it yet. We're just making this so that when we come to actually do this step in organization, we can do it quicker. So this is actually a higher mathematics tool which we use. Even if you go to the higher mathematicians, they are going to be using this technique, not just for derivatives, but for advanced mathematics. Being organized can make you give the organization of the new actual harder problem way easier. So let's actually do the derivative of this and the derivative of this. So the derivative of sine of x, cosine of x. Well, this is just equal to cosine squared x minus sine squared x. Okay, so you may be wondering, I said that we will walk you step by step. So how do we do this? Well, the product rule. So uv prime plus u prime v. So let's take this u, this v. So uv prime, so it's u, sine of x, v prime is minus. So the derivative of cosine of x, what is that? Minus sine of x. So uv prime, v prime is just going to be minus sine of x. Then we're going to add it with u prime v. So sine of x is cosine of x, and cosine of x is just cosine of x. So now essentially, this will just become cosine squared of x, and this will just become minus sine squared of x. So essentially we're going to have minus sine squared of x plus cosine squared of x. And we can essentially just write this as cosine squared of x minus sine squared of x. So as you may know, in calculus, many people say it could be your calculus teacher, or if you're just learning calculus at a young age, lots of people are going to say do the algebra first, then the calculus. Well, why is that reason? Because when we're trying to take the integral or derivative of something, we try to find the rate of change. And when we're trying to find the rate of change, we can simplify, then find it, because that's just the same thing. And when we simplify it, it's going to be much more easier to calculate. When you're in algebra, first you have to do the algebra or arithmetic first, then we can solve. And sometimes actually it's arithmetic first, because it's kind of arithmetic algebra in the mix, because if we have an equation, we want to simplify and combine sides first, which is kind of arithmetic and algebra combined. So essentially we're going to do the algebra first, then the calculus. But right now we don't have that much algebra, so we're just doing the calculus. But what about the trigonometry? When we're doing integrals or derivatives, sometimes doing the trigonometry, we can do it first. Like for example, if we have the tangent of x or the cotangent of x, we can just split it, because tangent of x is just sine over cosine of x, and then sine x over cosine of x, and cotangent is just cosine of x over sine of x. So essentially we can just split it up, then do the integral or derivative. But right now what we can do is we can just integrate, now do the trig identity. In our past video, we did 2 or 3 videos on trig identities. One of the videos was 30 minutes long because trig identities are that important. So one of the trig identities was a double angle trig identity. And if we have this just means cosine of 2x. So this is what we can substitute for. So essentially, if we just erase most of our work here, we can write, this is just equal to cosine of 2x. So now that we have done this, we have to calculate the derivative of the bottom side. The derivative of the bottom side is easy because it's just the sum rule. So if we were to calculate the derivative of 9x squared plus cosine of x, the sum rule will just say we calculate each term, and then we just use the arithmetic operation to combine. So 9x squared would be 18x, because the formula nax to the n minus 1. If n is equal to 2, a is equal to 9, we're going to have n, so 2 times n, so 2 times 9, x, then n minus 1. Minus 1, this will just be 18x raised to the first power, which is just 18x. So essentially, this is what we get. And this is just a basic formula. Sometimes, even when we're doing advanced mathematics and we have more experience, we want to check our work again. And sometimes we get confused. So this formula is really useful. But once you're just progressing through it, you don't really need to calculate using this formula. So we have 18x, and then we're going to have the derivative of cosine of x. Well, the derivative of cosine of x is minus sine of x, so we can just write minus sine of x. Essentially, this will be our answer. So, we've got both of the derivatives, and we've got them noted, so let's just write this a little smaller. So, 18x minus sine of x. Now what we can do is essentially, we can just make it again, and now just do the organization. So what's the organization? Well, for the quotient rule, we need to first drag this up. So we can just have 9x squared, and it really doesn't matter what order you're doing it, because commutative property and addition property just state so. So if we have 9x squared, and then we're going to have, so plus cosine of x, we can use, instead of using the formula, we can just use common sense right over here. So is this taking the derivative of something? Well, no. We took the derivative of this and we got this. This is not anything like this. Well, in a graphical scale, it could be related, but right now, it doesn't look anything like this. So we know that this is not the derivative of something. So the next term that we're going to multiply by has to be the derivative of something. So we're going to take cosine of 2x. Now, we're going to subtract it, since this is the quotient rule, with the derivative of this, which is 18x minus sine of x. And then, what we're going to do now is just put this one, sine of x, cosine of x. So now, let's write it more higher. Essentially, we're going to have 9x squared plus cosine of x, cosine of 2x minus 18x minus sine x, and then sine x cosine of x. So essentially, if we write this smaller, so essentially this is going to be part of our answer. Why? Well, we were just done with the numerator. So if you think this is a pretty long answer, well, we have to do the bottom part too. So the bottom part, well, for the bottom part, what we're going to do is we need to square this term, so it will be 9x squared plus cosine of x squared. And this is not the answer symbol. So if you think that this is the answer symbol, this is not. This is the divide symbol. Divide symbol. And we can erase the bottom. So therefore, we've got our answer. So I explained step by step how to do this, but what rules do we use? Well, I told one rule, which we used the sum rule. So we used the sum rule. We didn't use the chain rule, but you could kind of say this is the chain rule, but actually it's not the chain rule. So we didn't use chain rule, so chain rule we can cancel out. But we did use product rule and quotient rule. The product rule was when we were doing the derivative of sine of x and cosine of x. Really, if we were just going to do this step by step, we could just use the quotient rule, and boom, we could only use one rule to solve this, and maybe the sum rule. But actually, the quotient rule is essentially just the product rule, except we're dividing, and the denominator is going to be squared, and then we're just going to subtract instead of add. So the quotient rule essentially is the product rule, just with the little variations. And now that we were doing it step by step, we did use also the product rule. So the product rule we also used. Now, we're going to have the sum rule. The sum rule was the best, and it was the easiest, so we did use the sum rule. But the chain rule wasn't, so we can just erase the chain rule and write this. Chain rule. So, we need to review this, but this one is the one that we have to do today. So, chain rule is the one we might do next video. But, so now that we have done this problem, let's write our answer over here. So, 9x squared plus cosine of x cosine of 2x minus, we can write 18x sine of x, minus sine of x, and then we can write sine of x cosine of x, all divided by 9x squared cosine of x squared. So this is essentially going to be our answer. And essentially I didn't write the division symbol because some people might think that would just be the answer symbol, so I just wrote the actual division symbol. So this essentially is going to be our answer, and this was a pretty long process. So now, let's do the second, which is an integral. And this integral is complicated, and it's not complicated. So let's do this. So as you see, we have made a video on substitution, which we're going to be using today. So we have the integral of 9x over x squared plus 7. So we have this integral. How do we solve this? Well, let's use basic integration properties to see if we can solve this. Well, sum rule, no. And there is a sum rule for the integral, just taking the integral of each term. But we can't use that right now since it's multiplication. We could raise this to the -1 power, then multiply like that, and use integration by parts, but that's going to be complicated, and we might not get the right answer. So what can we do? We'll use substitution. Use substitution. What does use substitution say? Well, use substitution says that we can substitute u for a specific variable or a specific term, and then we can use du, and we can use the relative terms, and then we can solve this easier. And remember, we have to put the dx over here, by the way. So dx. So now let's do this. How are we going to attack this? Whenever you have a problem of this type, sometimes you're going to have a problem of this type that can use trigonometric substitution, but whenever you have a problem that you can't identify, so if it is a trig substitution problem, then this won't work. So always first, when you look at any problem, try to use substitution, then try the other things. So if you have a type of problem that looks like this, try to use substitution. Doesn't work, then trig substitution. But how can we use substitution? Whenever you have a problem like this that deals with use substitution, not trig substitution, what you can do is always replace u for the bottom. Most of the time. So we can say that u is x squared plus 7, and then du is just 2x dx. So now what we can do is we can just plug this in. So we're going to have 9 over 2 x over x squared. Oh, we have to substitute with u. And we can essentially write this du. Okay, why the 9/2? Well, if du is going to be 2x, we're going to have 9 over 2. So if x is going to be, we have 9x, and then we want to replace x with, so x we want to be du. What can we do? Well, what we can do is, since we have 9x, we want x to be a 2. Since x is going to be 2x, we have to replace, so we can divide by 2. So, and then just have 9 over 2x. And we can essentially write this du. And if du is 2x times 9 is 18x over 2 is 9x. Essentially, that's it. So what we can do is, if du is equal to 2x, we need to get 9x. So 2x times what factor is equal to 9x? Well, 9/2. Because the 2's and 2's cancel, and then we'll just get 9x. Or what we can say is 2 times 9 is 18 over 2 is just going to be 9. So 9x, so essentially that's why we're replacing 9/2 du, and then we're just going to replace u. What's so special about this? Well, that's what we're going to be when we do the observing part for this integral. What we're going to be doing that's special for this problem is that, so now that we have this, what we can do is go over here and just write this. Whenever we have du over u, this is going to be the natural log. So we can say that the natural log, and then u, which is going to be x squared plus 7, x squared plus 7. And then what we can do is we can put 9 and divide by 2. Why 9 and divide by 2? Well, since we have 9/2 x. So since we have du over u, it's going to be the natural log, and then 9/2. And whenever you have a specific function, 9/2 times, let's say 4, it's always going to be, when we multiply this, so essentially we can just write 9 times 4 over 2. So whenever we have 9/2 times a specific constant that has a denominator of 1, it's just the top value. You can ignore the denominator. So we're just going to multiply with the numerator, and then boom, we can have it. So essentially that's what we're doing here, and this will be our answer. So let's review what we did in the technique of use substitution. This is one way use substitution can be used. Use substitution is actually a very, very cool method. Some people even use it for advanced mathematics like real analysis and complex analysis, which are more derivatives, but also have integrals. So what did we do over here? Well, what we did was we first took this and we made u is equal to x squared plus 7. So whenever you look at a problem and it's like this, try use substitution first. But then, when you have a problem after use substitution, try it, then see if you get a reasonable answer. Then try trigonometric substitution. And when we make a video about trigonometric substitution looks more different than this. And it could result in the same answer, but try use substitution first, but if it looks like a trig substitution problem, then do trig substitution. So we're doing use substitution over here, so we did use substitution. Most of the times when you have problems like this that work for use substitution, the denominator is always going to be the u. The d is just going to be the derivative, so this is just going to be 2x dx. Now, remember we also have to add the plus c, so what we do is just replace it. We get 9 halves du over u, and then what we're going to have is just replace this, so 9 ln of x squared plus 7 over 2 plus c. And this will be our answer. So that's how we can use substitution over here. And if we write this over here, so this will be our answer. And right now we're going to split this problem set into 2 videos. So this is going to be the first video, and we're going to be doing the 3 problems. And in the next video, we're going to be doing the rest of these. So we're going to be doing 3 problems in this video. We covered the first and the second, and we're going to do this one. And the next video of part 2 of this, we're going to be covering 4, 5, 6, and 7. And 7 is a bonus one because it's a very high mathematics, higher than calculus. Differential equations, by the way. So that's a hint. And now we have to do the limit as x approaches 0 of x squared plus 9 over x plus 3. So this is very simple. We can do this in one step, and it's very logical for most of you, but let's explain the theory behind this. A limit is trying to use when we're approaching something. So this limit is just saying when we have, so it's saying when x approaches a value, then what happens to f of x? That's essentially the thing. So as x approaches a value, then what happens to f of x? Well, when we're doing most of the times limits, we can just substitute 0, and that's what we're going to do. So we'll get 0 plus 9, because 0 squared is just 0, over 0 plus 3. This will just be 9 over 3, and therefore we'll get 3. So this is equal to 3. And we've also made a video about limits. We made a L'Hopital's rule, which is limits, but it's more advanced when we're using derivatives, and we will make a video on limits soon. So now that we have done these first 3 problems, I can write it over here. So answer equals 3. So now that we have done this, we can make this to a conclusion. If you like this video and if you like this channel, please subscribe to learn more. Thank you.